Hello guys, welcome to my channel Learn with an Access. My name is Rohit Dasi. I am passing BE from SVC College of Engineering and I am in the third sem. Today's subject is TSA data structure and application, and today's topic is multiple queues. Welcome everyone. Today we will be diving into a fundamental data structure concept, multiple queues. Queues are widely used in computing, and when we deal with multiple queues, things get even more interesting. Let's explore what multiple queues are, why they are needed, and some of their key applications. What is a queue? To understand multiple queues, let's first revisit the basics. A queue is a data structure that follows the first in, first out or FIFO principle. It's like a line at a grocery store. Whoever gets in line first gets served first. A queue supports two main operations. NQ, adding an element to the end of the queue. DQ, removing the element from the front of the queue. Some practical examples of queue of include printers. Jobs sent to a printer are processed in the order they are received. Task scheduling. In operating system, tasks are queued for CPU processing. Introduction to multiple queues. Now let's move from a single queue to multiple queues. A multiple queue system is a simple a collection of more than one queues. In some problems or scenarios, using a single queue may not be efficient enough. Why use multiple queues? Different types of tasks or process may be need different levels of priority. Some tasks may require different resource and need to be handled by separate queues. Load balancing. You might have multiple servers each with its own queue to process tasks. Common types of multiple queues. Parallel queues. Multiple queues operate in parallel. Each queue works independently. Second, priority queues. Here queues are created based on priority. For instance, urgent tasks can be go into a higher priority queues and less critical tasks into lower priority queues. Circular queues. This wrap around and can serve multiple different purposes, including managing multiple tasks in a circular fashion. Implementation of multiple queues. So how do we implement multiple queues in a code? Let's take a look at the logic. First, array of queues. One way to implement multiple queues is by using an array of queues. For example, let's say we k queues. We can create an array of size k, where each element of the array is a queue. As an example of an array of queues is equal to square bracket for in range size of k. Encaving operation. Def encave cave name num comma element cave num dot append element into the queue. DQ operation. Def dq num if q dq num return q num dot pop, else return q is empty. Second, linked list of queues. Another approach is using linked list to create multiple queues. Each node in the linked list can represent a queue, and each queue can have its own list of items. This provides dynamic allocation unlike arrays. Third, priority queue implementations. In a primary queue system, tasks with different priorities are inserted into separate queues. For example, priority queue system. Higher priority is given an array and lower priority is also given an array. Defining a enqueue priority comma task. If priority is equal to high priority going to be appended task, else low priority will be appended task. Defining a DQ priority. If high priority, return high priority dot pops, else low priority return low priority dot pop, else return no task in queue. Application of multiple queues. Let's now explore where multiple queues are used in real world applications. First, in operating system OS scheduling. In OS scheduling, multiple queues are used to manage process with different priorities. For example, multi-level queue scheduling divides process into several queues based on priority or type interactive processes, batch jobs, etc. Each queue is managed independently and higher priority queues get CPU time more frequently. Second, network traffic management. Routers in network use multiple queues to manage incoming and outgoing data packets. Time sensitive data like video streaming can be sent through a high priority queue while less urgent traffic like email goes into a lower priority queue. Third is customer service systems. In real world services like call centers, multiple queues are used to direct callers to the appropriate departments. For instance, a company may maintain separate queues for sales, support, and billing inquiries. Fourth, multi-threaded processing. Multiple queues help manage different threads working on distinct tasks. For example, in a web server, multiple queues can handle incoming requests, background processes, and file transfers simultaneously. In summary, queues are essential in various fields, and using multiple queues adds a layer of efficiency and flexibility in managing different types of data or tasks. Whether it's in operating system, networking, or customer services, multiple queues ensures that the right tasks are handled in the right way. Thank you for joining today. I hope you are gained a clear understanding of multiple queues and how they are applied in the real world. Do like, share and subscribe. Thank you.